This is section 10.3 using permutations and combinations part 2. In a multi-part task that satisfies the uniformity criterion, if repetitions are allowed, use the fundamental counting principle. If repetitions aren't allowed and order matters, it's a permutation. If repetitions aren't allowed and order doesn't matter, it's a combination. Example 9. How many ways can 3 toys be distributed to 7 children if a child may receive anywhere from 0 to 3 toys? A child can get more than 1 toy. So we're going to use the fundamental counting principle. Each of the 3 toys can go to any of the 7 children. So that first toy can go to 7 children, the second toy can go to 7 children, and the third toy can go to 7 children. 7 times 7 times 7. The toys can be distributed 343 ways. Example 10. How many ways can Club N select 3-member committees with exactly 1 woman? Remember that Club N is Alan, Bill, Kathy, David, and Evelyn. When choosing committees, order does not matter. Means it's a combination. First, we're going to choose 1 woman, and there are 2 women in the club, so it's going to be 2 choose 1. Once we choose 1 woman, we need to choose 2 men for the committee. There are 3 men in the club, so it's going to be 3 choose 2. To find the total number of combinations, we need to multiply these 2 options. 2 choose 1 times 3 choose 2. 2 factorial divided by 1 factorial times 2 minus 1 factorial times 3 factorial divided by 2 factorial, 3 minus 2 factorial. 6 different committees with exactly 1 woman are possible. Example 11. 10 of the 48 men in a fraternity will be allowed to attend a gala event this weekend. How many ways can the men be selected? Order does not matter. No repetitions are allowed. It is a combination. There are 48 men, and we need to choose 10 of them. Use the combination formula. 48 factorial divided by 10 factorial times 48 minus 10 factorial. 48 factorial divided by 10 factorial times 38 factorial. 6,540,715,896 ways to choose 10 of the 48 men in the fraternity. Example 12. When the 10 men selected arrive at the gala, 4 are selected to escort the homecoming queen candidates. How many ways can this selection be made? Order matters because different men can be paired with different women. Repetitions are not allowed. It is a permutation. 10 things taken 4 at a time. 10 factorial divided by 10 minus 4 factorial. 10 factorial divided by 6 factorial. 10 times 9 times 8 times 7. There are 5,040 possible selections. Example 13. How many ways can 9 baseball players be placed in groups of 4 infielders, 3 outfielders, and 2 pitchers and catchers? Order does not matter, so we're talking about combinations. There are 9 players, and we are going to choose 4. Then there are 5 players left, and we are going to choose 3 for the outfielders. And then there are 2 players left, and we're going to put them in the catcher category. So it's 9 choose 4 times 5 choose 3 times 2 choose 2. Using the formulas, it's 126 times 10 times 1. There are 1,260 possible ways. Example 14. How many ways can the letters in the word Mississippi be rearranged? Not all the letters are different, but there are 11 different letters. There are 4 S's that can be arranged in 4 factorial ways. There are 4 I's that can be arranged in 4 factorial ways. And there are 2 P's that can be arranged in 2 factorial ways. 11 letters, so 11 factorial will be our numerator, divided by 4 factorial times 4 factorial times 2 factorial. Dividing by those takes into account the repeated letters. There are 34,650 ways the letters in the word Mississippi can be rearranged. That's section 10.3, using permutations and combinations.